All right, everybody, I want us to understand how the three basic Pythagorean identities can be created. Okay? And then we'll go ahead and break down problem number 12. So, the most basic one that everybody needs to know, memorize, is sine squared theta plus cosine squared theta equals 1. That's the one we talked about just recently. Okay? Now, what I'd like us to do, though, is I'm going to write it down in 3 different colors. Sine squared theta plus cosine squared theta equals 1. I'm going to write it down once again. It may not make sense right now, but it should in just a little bit. And one more. Let's go. Okay, so this is the first one. Sine squared theta plus cosine squared theta equals 1. In the second one that's in red, what I'd like you to do right now is I would like you to divide every single term by what is called sine squared theta. Okay? So divide everything by sine squared theta, just like that. Now, what is sine squared theta divided by sine squared theta? 1. Plus. Now, if you guys would look right here, this is one of the examples of what's called a quotient identity. So if you looked at your little paper that has all of your little notes in your journal that you spent so much time and energy writing, is what? That's right. That is equal to the cotangent squared theta. So something you need to be aware of is this. Anytime you see a cosine squared theta over a sine squared theta, that's the exact same as saying the cotangent squared theta. That is called a what identity? A quotient identity. Now, over here, 1 divided by the sine squared theta. I'm going to put another arrow. This is not a quotient identity. This is called a reciprocal identity. And what is this reciprocal identity technically equal to? Cosecant squared theta. This is one of the other Pythagorean identities. You might see it as you might see it written as cotangent squared theta plus 1 equals cosecant squared theta. These mean the exact same thing. 1 plus this is equal to this plus 1. Okay. All right, so I'm going to move over here. So I gotta have a little bit of room. So what I'm going to do real quick is I'm going to divide every single term. Divide every single term by the cosine squared theta this time. So I'm dividing everything by cosine squared theta. So, let me highlight it. This right here is, once again, everybody, this is what's called a quotient identity. What's the quotient identity for sine squared theta over cosine squared? That's right. That's tangent squared theta. And what's cosine squared theta divided by cosine squared theta? And the other reciprocal identity, what's the reciprocal identity for this guy? Yeah. So the whole purpose of this quick little video, all right? The whole purpose is to show you how to start from what? How to start with this Pythagorean identity and go to this one and this one. You should have all 3 of them in your journal. Okay? But I want to show you how they were created. Like it wasn't just magic, right? Okay? Call it math magic. those mathematics. All right. So everybody, could you, right now, look at number 12. Look at number 12. Look at the cosecant squared theta. Could anybody look at what we just did, if you were paying attention, and tell me, is the cosecant squared theta equal to anything that we just did? So what is the cosecant squared of x actually equal to? All right, so write down the cotangent squared x plus 1. So right now, what I'd like everybody to do right now on problem number 12 is use the process known as substitution. And wherever you see a cosecant squared of x, replace it with the cotangent squared of x plus 1. So here we go. Cotangent squared x plus 1 minus cotangent squared of x. All of this is now in the numerator. So all of this right here. What cancels out? The cotangent squared of x and the minus cotangent squared of x, they zero out. So what's the only number we have left now in the numerator? 1. Thank you very much. All right. Right here, everybody. This section right here, sine of negative x, is also equal to negative sine of x. So what I'd like you to do right now is simply replace this and put this in the denominator. So right here, in green, I'm going to put a negative sine of x. Now, this is where I need you to really look carefully at what's called your quotient identity. So look for right now. Look for your quotient identity. So I'm going to put right here times. I'm going to put my quotient identity. And what is the quotient identity for the cotangent of x? Yep. Cosine of x over sine of x. Now I'm going to stop, take a look at this. Don't have to answer the question right now because I haven't asked. But right now, does everybody see how this sine of x right here will cancel out the sine of x? Yes, so right here, these will cancel out. And so what's the only thing we have left remaining? We have a negative sign, and we also have a cosine of x. So right over here, to the right, I'm hoping that you guys see the pattern that I'm trying to do. I have a 1 still in the numerator. What are the only two things left in the denominator? A negative sign and a cosine of x. Would you agree so far that this right here that we started with is a heck of a lot more simple? Now, we're not done, but we're like really, really, really close to done, because the final thing I want you to look for is what's called a reciprocal identity. So what is the reciprocal identity for 1 over cosine? That becomes the secant. But we're not going to put just the secant. We're going to say it's the negative secant of x. And that's your final answer for this simple. Okay? Now, I realize that's a lot of work. And what are we looking for? We're looking for patterns. And it went from all of this, which is a bunch of stuff, to finally, what did it finally equal? Negative secant of x was our final answer. But I want to see all the work that got us there. All that work is the important part. All right, the final problem that you're going to be working on today. All right, you're going to be working on a problem right here. All right. It says Raymond and Delaney are flying a kite. So what I'm going to do is draw a little kite. I just draw a little kite. I know it's not a very good kite, okay? But I did not build it. Okay? Alright, so there's a kite. Alright? And now, from that kite, there's going to be a certain height. That kite is up in the air. Okay? And it is, by the way, the string is attached to the ground. So let's pretend this string right here is attached to the ground. Okay? And this is the height right here. This is the height. And this is the length of the string. I'm going to call it L. Now, the formula is L over H is equal to the cosecant of theta. Okay? Where L is the length of string and theta. Here's theta. Oh. Go back. Come on. There's theta. Okay? Now, what formula could Raymond and Delaney use to find the height of the kite if they know the value of sine? So I want you guys to go ahead and I want you to find the what? Find the height if you know the value of sine. So here's your formula. Okay? Use your properties for trigonometry and try to solve it. Now, if you need to get inspired, you might want to just listen to the song where you're playing kite. Okay? All right. By the way, what did I say replace cosecant of theta? With what? I said replace it with 1 over sine of theta. We're replacing the cosecant of theta with 1 over sine of theta. Oh, now, if you look carefully, can we solve for the height? Sure. Because now we can do what? Cross multiply. And when you cross multiply, you get h times 1. Which is h. And what is h? What is the height equal to? L times sine of theta. Now, why did we have to convert it? Because we only knew the what? Value of sine. So if you know the value of sine, and you know the length of the string, then the height of the kite will be L times the sine of theta. And that's what you would use to find the height